Howdy and welcome back. So we'll continue or I guess begin our discussion with memory allocation overview. So here are the three different areas where we can allocate things within our program. We'll see that there's the stack, the free store, as well as the static code region. So in the stack, this is going to be allocation of memory for variables. So name objects. When you write something like int I, notice that I is bound to some sort of object out there in memory. It's a named object because you've made that binding. So that variable is going to be allocated on the stack. The size of variables, again, named objects, must be known at compile time. And in the last, lesson or so, we really kind of got into this idea that each time you call a function, a new block of memory called an activation record is going to be added to the stack to hold these sorts of variables. Now contrast this with the free store, which we're not going to get into today, but we will motivate the necessity for it by the end of today's lesson. This region of memory is where we're going to dynamically allocate objects in this region known as the free store. The cool thing about this region is the size of objects that are going to be allocated here do not need to be known at compile time. This is this contrasts the stack where we have to know the size of all those variables. And again, we'll see why here shortly. Furthermore, for the free store, what we can actually do is while the program is running, we can request memory to allocate objects in this region. And then there's the static code region. And this is allocation of memories for variables declared as static as well as global variables. So with that, let's go ahead and move into this allocation of memory to variables discussion here.